welcome to the presentation. I'm Caraline, I work at Mpathic, and we are the machine learning AI use case that so many of you raised your hands for today. Quick about me, I'm a senior machine learning engineer at Mpathic. We specialize in conversational AI, specifically related to clinical outcomes, but I have this because it's just my favorite thing. And I also have my universities at the bottom, UConn and NYU. My background before I was a machine learning engineer has been in data engineering, software engineering. I've been on the NYC scene for the past 12 years at hedge funds and startups. So now I'm working in healthcare, so it's a little bit of a shift. So Mpathic, we are pre-A company. We're pretty young. We have about 20 employees. So it's a really fun, dynamic environment. So we are a clinical conversation AI company, and what does that actually mean? Well, it means that our customers are running mostly clinical drug trials for like antidepressant drugs, like MDMA-assisted therapy, think these types of things, and we are observing the conversations that the patient and the therapist are having and trying to really just provide observability from an ML standpoint and like model the conversations that they're having. And it does two things, really. There's two outcomes. One is to ensure the patient safety. So we want to make sure there's no misconduct happening, the patient's being treated very well. And also we're scanning for compliance for the therapist, making sure they're saying the things they're required to say when they're administering the drug trials, and speaking with the patient about all of these things. So drug trials, here I have outlined, this is a very common 10-year process to outline what it actually takes to bring a clinical drug from studies to actually getting FDA approval. And it's a really lengthy process. I think there's 3 phases for every, I think that's a required regulatory thing, 3 phases. But there's a couple of years each phase. And really they take, you see there's 20 to 100 people, 300 people, and all of these people have multiple sessions. So it's thousands and thousands of hours of audio recordings and audio conversations. And how do you ensure compliance? How do you ensure safety? Do you have someone listen in? You could hire a bunch of people to listen in, or you could kind of work with our company. And we're trying to find red flags in these thousands of hours of audio that, could cause you setbacks for many years in your clinical studies. The data in clinical therapy, you might think it kind of looks something like this, and it actually does for a lot of the time. And you can click the audio sample just to get a flavor of what that.
Oh, I can't play the audio file. I have to request access.
Oh, no! Okay. Well, that's a bummer, but okay. Just think of like this type of scenario where the patient's asking questions. Yeah, so but the reality is like these types of things that we see in movies, that's not actually how people talk. Like the reality is like the data actually looks pretty different. These recordings look pretty different from what you might hear in movies and TV. Yeah, so there's people crying, asking for tissues. There's often like background music playing with like people singing in the background. So we have to kind of figure out like who's talking. Is the patient talking? Is the therapist talking? What are they saying? And like sometimes we even have instances where there's a recorder like this, but it's covered, so you can't even really hear it the whole time for the 8 hours. So it's really, really hard actually, and it's messy. But one of the first things that we have to do, along with getting the transcription, before we can figure out what was even said, we have to figure out who was talking at any given time, right? So you're doing kind of like a speaker segmentation and speaker fingerprinting to kind of assign different transcript pieces to different speakers in the conversation. This is kind of what it looks like, what our flow looks like in Mpathic, right? We take the raw audio, get the transcription, we build models, and then we build advanced analytics, right? So how do we even build models? Before we had ClickHouse, we were on Elasticsearch, and you obviously can't do joins. It was really difficult to understand trends in our data, relationships between our data. We'd have to pull the data down into like a local database on our computer and try to do some aggregations there. It was a really miserable experience. Honestly, it really limited our understanding of the underlying trends within our data. So we definitely were looking for something that would help us share the data, do joins effectively. And also, we were doing these ML pipelines where we had to spin up EC2 instances and build our pipelines up there, build pandas, which takes forever. It takes like 10 minutes just to build that. And you also have to pay for that, right? So like it was just not a great experience for me and my team. We were not happy developers. So we actually spent like most of our day building these pipelines. Like when we want to launch an experiment, we have to spin up the EC2 instance, like build our project there, run the experiment. And it was a lot of time and waiting. And honestly, it just like killed our innovation, our innovative cycles. So we obviously, when we were finding ClickHouse, we obviously knew that we needed to build complex ML pipelines fast. I don't want to have to wait forever. I want to be able to innovate on the fly. I need stuff to just work. We're a small company of 20 people. I want to just implement something, and then hopefully it works, nothing breaks. I don't have to even give any attention to it because I don't want to be a DBA anymore. So where we plugged it in was initially just as a data store, right? We wanted to build our ML models off of what we put in the data store, just the transcripts that were annotated. But eventually, we started to realize how useful the aggregate functions are and how useful it could be for a lot of the analytical work that we were doing. So it's kind of now plugged into almost every piece up here, and it really acts as a central data hub for ML. So it's ML's central data hub. It's what we use to do all of our work. So it's really ingrained in everything that we do now. Yeah, so some of the things that we do in our pipelines is we do, on the top, I'm like not gonna point with this, like string extraction is so easy. I was so impressed by that when we first started using it. It was like the easiest thing ever to set up. The aggregation functions are really easy to do. You know, we're combining labels across sessions, across different trials. We need this to work fast. I don't wanna have to wait forever for my experiment to run. And also you can see we're also doing undersampling. So undersampling, like sampling functions are typically something that ML would do on a separate compute. So we'd have to deploy separate compute, like build the data there. But we can actually do these things directly with ClickHouse. So we don't actually have to pay for additional compute. We don't have to spin anything up or wait for it, which is pretty cool. We actually don't use EC2 instances at all anymore. So that's a really nice win for my team. Yeah, and it's fast. So I have never had any issues with speed. Yeah, it also helps us to understand our data better. Remember how I said initially that when we were on Elasticsearch, we couldn't do joins. So now we can kind of understand our data a little bit more. And this is some unsupervised clustering that I had done when we first started using ClickHouse. And this was to kind of understand if you have a bunch of data that's confrontational, like people are very upset in the session, they're swearing, they're saying like, you're an idiot, et cetera, is that different from a passive-aggressive confront that we have labeled here? So we kind of want to understand, if we want to improve our models, we have to understand what the data that we're looking at is, and we can break it up to actually do a better job at classifying those subclusters. So you can see up here, I did some, okay, there's some swearing in here, but but you can see like these are the centroid embeddings, right? Some of them are very direct and upfront, and some of them are a little bit more passive-aggressive. So for us, this really helps us to see, should we be changing the way that we're modeling in order to get better modeling results. And so like I said, it's we have faster pipelines, faster dev cycles. Me and my boss are super happy when we're working on these things. We could experiment in a flash, run things in parallel. Yeah, so we went from 15 minutes for our workflow to a 4-minute experiment cycle. So that's a pretty big improvement in just swapping out the EC2 instance and doing everything that we're doing on a ClickHouse compute. And yeah, for us, it's really become just the backbone of all of our ML infrastructure, which is, I think, kind of like a cool, unique use case for ClickHouse. So yeah. Yeah, so what does our future look like with ClickHouse? We would love to get our hands on the MCP integration and understand deeper advanced analyses for better clinical outcomes. So if we could understand, you know, what is the concept drift in our data, which is a very important thing to analyze for machine learning models. Yeah, so that's our goal. We want to be doing these things. We want to be adding multimodal analysis. So that includes not just metadata and biomarkers, but also the audio itself we want to start working with. And hopefully we can do that with ClickHouse too. Okay, reflecting on our experience. So we have 20 people on the team, and I don't want to spend any time doing DBA work, sysadmin work. I don't want to think about it. I don't want to query a system table. I don't want to like execute explain plan. I just want this to work, and I want us to be able to scale without having to, you know, kill a hanging transaction, query transaction, right? And for me, ClickHouse really works. I don't have to think about DBA work, which is awesome for me because it unblocks me and enables to do more of my job more effectively because I don't have to worry about sysadmin stuff. I don't have to worry about owning this infrastructure because I've never had any problems with it. Yeah, I don't want to switch. There's no reason to switch, and I'm happy. So, yeah. And for ML teams, I feel like it's pretty cool to say that ClickHouse is the backbone of all of our ML infrastructure. Like we do all of our pipelining through ClickHouse. It lightens our stack and our wallet, and we're using more and more aggregate functions over time as we get comfortable with them. So I guess let me just step back. Like I said, at first we were using Elasticsearch when we first started using ClickHouse, and moving all of these like deeply nested JSON objects into ClickHouse, it ends up that's not really what ClickHouse is made for, but that's kind of expected, right? So we got a couple of out-of-memory errors, but quickly just flattened some deeply nested schemas, and that was the solution for it. So that's just like a learning lesson for anyone who's migrating from a deeply nested object store. Okay, that's it. Okay, thanks everyone.